Chapter 6 Introduction to Linux. Most people have never seen Linux. Almost everyone uses it every day. Every Android phone runs a Linux kernel. The majority of web servers, cloud platforms and supercomputers run Linux. The International Space Station runs Linux. It is, by almost any measure, the most widely deployed operating system in the world, and it's been hiding in plain sight. In this chapter, John's class opens the Linux terminal for the first time. No graphical interface, just a black screen with a blinking cursor. It looks intimidating. It sounds intimidating. But what they discover is a language, direct, powerful, and once understood, faster than any graphical interface for the tasks that matter in IT. Key concepts: what Linux is, why it matters, the terminal and why it exists, essential commands, the Linux file system, and package management with app. Let's get into it.
Week 6, Linux. You opened the terminal, black screen, blinking cursor, and honestly, it looked exactly like every hacking movie I'd ever seen. I felt slightly cool and completely lost at the same time.
Which is a very normal reaction. The terminal looks intimidating precisely because it's unfamiliar. But once you learn the language, it becomes one of the most powerful tools you'll ever use.
You started with something that genuinely surprised everyone. Linux is the most used operating system in the world, and most people have never seen it.
Because it's invisible to most users. Every Android phone runs a Linux kernel. The majority of websites and web servers run on Linux. Supercomputers, the International Space Station, most cloud infrastructure, Linux. People use it every day without realizing it.
So what actually is Linux, like technically?
Linux is a free, open-source operating system kernel created by Linus Torvalds in 1991. The kernel is the core, the part that directly manages hardware. Around the kernel, distributions, or distros, package it with tools and interfaces to create complete operating systems.
Ubuntu, Debian, Fedora, Kali Linux, those are all distros, different versions built around the same core kernel.
Each with different purposes. Ubuntu is beginner-friendly. Debian is stable and server-focused. Kali Linux is built for cybersecurity and penetration testing. Raspberry Pi OS is optimized for the Raspberry Pi hardware. Same kernel underneath, very different experiences on top.
We used Ubuntu in our virtual machines, and then you told us to forget clicking and start typing.
The terminal. Why use it instead of a graphical interface? Speed. One command does what 10 mouse clicks would. Automation. You can write scripts that repeat complex tasks automatically. Remote access. You can manage a server on the other side of the world without a graphical interface. Precision. You do exactly and only what you intend.
You said the GUI is like a restaurant menu. You choose from preset options. The terminal is talking directly to the chef. You can order anything, customized exactly how you want it.
And significantly faster once you know what to ask for. Let's go through the essential commands because these are the vocabulary of Linux. ls lists files in the current folder. cd followed by a folder name moves you into it. cd ... takes you back up one level.
pwd, print working directory, shows you exactly where you are in the file system. mkidr creates a new folder. Touch creates a new empty file.
cp copies a file. mv moves or renames it. rm deletes it. And rm has no recycle bin. It's gone immediately. That's slightly terrifying.
Which is why you're careful with rm. And then sudo, superuserdo. It runs a command with elevated access permissions. You put sudo in front of any command that requires elevated access. Use it carefully, with great power, and all that. We did a whole series of exercises. Navigate to the desktop, create a folder, create a file inside it, copy it, delete the original, all without touching the mouse once. It felt powerful in a way I couldn't fully explain.
Because you were communicating directly with the system. No intermediary, no translation, just you and the operating system in dialogue.
Then the package manager. On Windows, installing software means finding a website, downloading an exe, clicking through an installer, hoping it doesn't bundle junk. On Linux, it's one command.
Sudo apt install, followed by the package name. On Ubuntu, apt is the package manager, advanced package tool. Software is downloaded from official, curated repositories, trusted sources, no third-party download sites, no bundled adware, no uncertainty about whether you're getting the real thing.
VLC installed in about 15 seconds. No website, no clicking next, no worrying. Darius said it felt like cheating.
It feels like efficiency. And updating your entire system, every application, every driver, every package, is 2 commands. Sudo apt update refreshes the list of available packages. Sudo apt upgrade installs all available updates. That's it.
2 lines to keep an entire operating system current. That's genuinely impressive.
Linux rewards learning it. The curve is real. It takes time to get comfortable. But for anyone going into networking, cybersecurity, cloud computing, or software development, it's not an optional knowledge. It's foundational.
After week 6, I started seeing Linux references everywhere, in job listings and documentation, and how the internet is actually built. It was like being let in on a secret that was hiding in plain sight the whole time.
That's exactly the right way to describe it. Welcome to the other side. The Linux runs the web almost single-handedly.
Linux is not a niche skill. It is the operating system of the internet, of cloud computing, of enterprise infrastructure. Learning to navigate a Linux terminal, ls cd mkdir sudo apt install, is learning the native language of the systems that run the modern world. The terminal rewards patience. The first few sessions feel slow and awkward. But as the commands become muscle memory, something shifts. You start working faster. You start automating tasks. You start managing systems at a level that a graphical interface simply can't match. In Chapter 7, we take everything we know about networking and add the layer that most people interact with every day, the internet and the web. What actually happens when you type a URL and press enter? What is DNS? What's the real difference between HTTP and HTTP? And what is a phishing email actually trying to do to you? Chapter 7, Internet and Web Basics. Coming up.